Good, wonderful, good day, wonderful, good afternoon. Good to have you all here in our class where we say, well, CFD meets virtual reality. I think everybody is kind of here. Classes is leading, is filling, and if you don't mind, we probably want to get started a little bit talking about how we can get actually CFD data to visualize it in 3D and actually to communicate actually our design to our clients, stakeholders, and actually basically to everybody else. I came up with this topic a bit of a while back because everybody was talking about virtual reality. It looks like nowadays you can even go to the supermarket and buy a virtual reality toast with a virtual reality banana, with a virtual reality milk. Everything is VR nowadays, so I thought, why not getting the engineering data, putting them into the virtual reality as well. Quick introduction, I work just for A2K, just employed like anybody else, so nothing special, just A2K is basically a consultant for Autodesk software, just to sell basically efficiency, trying to get everybody on board to communicate in a better way. And it's actually just showing you our Brizzy office. And we're actually based Australia, New Zealand, but also goes up to the Asia Pacific actually. And so that's basically what we do. Good partner with all kinds of people, going from Bluebeam, probably many of you know, going to HP and obviously with the drones as well. So everything which makes life a little bit easier, and so this is basically our resort. Also goes to 3D printing. The only thing is what we don't do is, well, I haven't tried actually to print 3D data, CFD data yet, but maybe it's one of the next projects. Good, so my role is to grab a glass of water that I can speak. So my role is basically looking after a lot of training and as application engineer, after a lot of workflows. If anybody has any questions, we have a booth actually down there. Just come around and say hello, and the boys try to help you out anytime, whatever you do. About me, why they asked me to work for them for a while back. I'm originally from Germany, sorry for my accent, can't change it. But moved actually to New Zealand about 12 years ago, and actually just with a plane, just arrived there and actually didn't fly back. Well, in the meantime, I got was a bit of an adventure, traveling through New Zealand and so on. Was not married, have no kids, no house and so on. Basically, was free. In the meantime, I'm married, have kids and have house, so I'm still there. And so it can happen to everybody. So, so looking after the whole visualization and simulation, and so it's important for me actually to see software not just as a line tool, but see actually software as a communication tool. We actually want to use this tool to make our communication easier, going after transparency and especially after efficiency, and that's actually one of the key points. So a bit of the forward to this, what we want to do is here that we cover a lot of software, and we are also in the cloud, and I've seen that sometimes the software takes a minute actually to fire up, to boot up, so love and bless the cloud. But if somebody wants to have the data set, I have documented the whole workflow actually with over 100 screenshots. You can take it, all the data, just take this, whatever you like. If you can't download it or just grab it, no problems. I can make this available to you. Send me an email or make somehow contact. It's not a biggie. And so I can share this also, that you can maybe also share this with some colleagues for that. So with this, we don't want to do any big crazy modeling because we just actually won't have the time for that, but we probably want to study the workflow. It's a workflow tutorial, so we will open up a couple of applications and we'll open up a couple of data basically for this. And so if anybody wants to do something crazy, then I just thought I need to throw this in because today I will do what others want, so tomorrow I can do what others can. And this just came up yesterday actually on a meeting with a friend, and because it's a little bit of a strange topic, why do you want to put CFD into virtual reality? Well, why not? Because we actually can do it. And maybe tomorrow it helps, and the whole building performance analysis is actually a multi-trillion-dollar market, because we most likely spend about $4 for facility management compared to $1 for the construction. And if you just think, if we have a $2 million building and we spend $40 million just maintaining our building, it would maybe worth just to rethink it. And I must say, the next financial crash can't be hard enough, can't be cruel enough to push actually BIM into visualization, simulation, and transparency, because we actually would need to know where actually the money actually goes. When we want to visualize this with CFD, we have here basically two workflows. The one workflow is that we go from Revit to Autodesk CFD as all what we know. And from CFD we can go to 3ds Max, and from 3ds Max we can go to Stingray. This is a very classic workflow. Works cool up to 3ds Max. From 3ds Max to Stingray we will encounter a couple of issues, because I can't bring Vertex colors into Stingray or 3ds Max Interactive, as Stingray is being called now. So I actually get just a black and white virtual reality model into Stingray. I can then populate to Oculus or HTC or for your mobile phone, whatever you're after. So it's a bit of a problem, because we are just humans and we are led by the visual. So we actually want to have our arrows, we want to have our flux shown actually somewhere in a couple of nice rainbow colors. And so you would need to actually recreate all the materials in Stingray. But, some clever guys came up with Dynamo, and in CFD, we can export actually our nodal results, and we can actually bring the results back into Revit, because with Dynamo I can produce a script which actually reads the data from CFD and creates some families. I want to demonstrate here this later on with a couple of examples of a data set with 820,000 nodes, which actually is working well, where we can actually bring the whole data actually back into Revit. And what we have in Revit as an authoring platform is actually accessible literally by any other software. So it's actually pretty good. A while back I had a presentation where we hooked up Revit with other 22 applications. We're round tripping. And so what you have in Revit you can present, and we make here use of Revit Live. And with Revit Live, which is actually also Stingray, we can actually easily also present this basically in color. So with the whole workflow, we actually would need to start with Revit. And what I thought is, if somebody is interested to follow the whole exercise, open up the model, study the models in their own time, because I believe that some of you are faster, some of you want to focus on Revit, some of you want to focus on CFD, some of you want to focus on 3ds Max, just go for it. Okay? So there are no rules. The only rule is there are no rules. Okay? So just explore this a little bit. In terms of the data set, what we have available here at this point, maybe just quickly need to bring this down. So I try to make a couple of notes here, if my mouse would work here. So this is what we basically discussed. So this is basically the one workflow, and that's the other one. So my preferred workflow is actually the one here, going down, and which makes life actually pretty easy. It's actually pretty easy and pretty cool. So somewhere we have a couple of example files, and you should find them actually on your desktop. And under the desktop where we have actually the example files, there's a folder I think with my name called Florian. And I quickly run you around how the whole files actually look like, what we actually basically want to encounter, and how this whole system, what I thought I want to set up, how this actually works. So following the path I was just explaining before, we have here, for instance, under 10, all our Revit models, and under 15, because there's one at the beginning, basically all the screenshots. Okay, so there are over 100 screenshots. We probably might skip a few because we just have 90 minutes. I try to spend about 10 minutes per section, means about 10 minutes about Revit models, 10 minutes about export to CFD, maybe 10 minutes about CFD and the projects and so on, so that we might in the end have also some time to answer maybe also some questions. Good, so exporting then to 20, I have here our exports actually are made available. Again, the same game. And at 25, we have actually our screenshots. If somebody wants to have this whole thing in a Word document, in a OneNote option as a PDF, or as a PowerPoint, just let me know. Anything you want, you can have. So it's everything. Following a good BIM practice, sharing equals caring. So we have also some analysis we want to jump later into and see this. All this has already been rendered. All this has been calculated and number crunched for you guys. So you don't need to, in no way, you need to run any analysis here, because if you would run this, it would take about an hour, and then we wouldn't have any time, or we wouldn't have any option actually to look into this. Similar like with 3ds Max. 3ds Max folder is being organized like any other 3ds Max project, where we find actually our stuff and scenes. If somebody wants to do a bit of a practice, I show you something about 3ds Max, because it comes actually out of the box with some CFD analysis, which is actually pretty cool. Some Stingray stuff. I did a run check for some ATC. So even I have actually Oculus here if somebody wants to try this later to experience this. Revit Dynamo, the scripts made available with all the nodal exports available here. You see they're a little bit larger. Can happen. As mentioned, we have about 820,000 nodes again. Always here with all the screenshots. When somebody's interested about the scripts in general, how we want to bring it in with Dynamo, here we are, grab it and just populate it and share it, whoever wants to do. Good, so we have here a Revit Live then later on, and if anybody is interested and want to grab the whole folder, theoretically, when we go here to our properties, it's probably about 60 gig for that. Sorry for that, can't change it. Good. So when you start any analysis with Revit for this, I want to now run through the section number 10. What we will find through our Revit models, following basically our screenshots here. And the idea is that when we run and if you want to actually work with Revit, come on, get this blue thing out. I wanted to use red. That we actually first want to open basically a model. I've just found somewhere an example model from Autodesk. We are probably all familiar with the Autodesk hospital, so it's actually straightforward. We can make use in Revit common techniques, be it for instance that we use a scope box or using actually also a section box with it. If you want to use a scope box with a section box together, they are about one Revit unit, which is actually 1 feet apart, so where we have an automatically section box around our scope box, for instance. So preparing basically the view, getting the model under control, what you're actually after. The visualization, what we have here, the whole scenario is that I have this room actually set up with a configuration of 7 diffusers by default. We see here 6 plus 1 makes 7 somewhere, and have another configuration actually with 4. And we want to, for instance, experience, or we can experience, which one basically might be maybe a better solution. I actually thought that the 7 one is better, but the analysis told me that the 4 is better, which is actually quite interesting for that. Good. Including, for instance, we know in this model that the HVAC model has been linked in. So I basically have just added this on to the HVAC model, and where we then actually can prepare. And we make then in CFD later on make use here of our surfaces to set up then actually here our boundary condition. So that's basically our first stop. So here in the Revit, we can here make use of our Autodesk metric hospital. We can just go basically to open. Under the open, we should find the folder under the desktop. There's the link to the folder I've just introduced to you guys. And under the T and Revit models, we find, for instance, here the architectural model. And say, for instance, we want to just open this up here, computer rattles for a second, and then hopefully we see some nice results of the model. Good. Sweet, brilliant. So we see on the left-hand side that here our HVAC model has been linked in. If I want to inspect my HVAC model, I need to go here, right mouse click, and actually need to unload it, because Revit doesn't like to open up two models at the same time, because we are working here with a relational database, and so hence isn't. If somebody wants to look into the model, I'm just using figured out that actually I locked actually my 3D view. Using a shift, for instance, the middle mouse button, we can quickly orbit the thing around, and the point of interest is actually here, somewhere in the back, where I actually put a couple of scope boxes. I tried, for instance, the scope boxes. If I want to communicate my design intent, I just give them actually also somehow a name that others actually know that this is a scope box, for instance, for the analysis. What we can do is, for instance, here, that's ready for my analysis, and so that I can actually immediately browse and actually jump to this. Revit offers us a pretty cool tool here if we want to communicate the areas of interest with scope boxes. First, under the view, we can actually set up scope boxes in a plane view. In a 3D view, it doesn't work. If I, for instance, select now my scope box, I can actually immediately create a section box around it. BX would be, for instance, the shortcut here, and then we actually are immediately in our area. Here, basically, of interest. If somebody wants to open this up a little bit, you can bring this a little bit further down. You can also make use here of the view cube on the side for that. And somewhere there should be maybe or maybe not a section box. And for instance, then we can actually open up and inspect actually this whole design, actually what we're after for that. The idea is just to warm up here a little bit with this model, that you get a little bit of a feeling for the geometry. Some CFD engineers, they never have seen Revit. I even was talking to Autodesk employees yesterday. They actually have never heard about Dynamo. It's not that everybody actually always knows everything. Also myself, I don't know everything. So hence, good. In terms of our model, what we have available here, for instance, this is part of our metric HVAC model. For instance, here, if I want to inspect it, I would need to quickly unload this thingy. We see that it's gone. It doesn't actually matter if we have this model linked in, because when we forward this to CFD, we can actually literally use any kind of geometry. It doesn't matter if it's linked in or it's not linked in. And even though if I want to forward this whole thing to Revit Live, it doesn't matter if it is linked in. Revit Live actually understands this easily. So what I will do is quickly, I'll just try to open up here my metric, and I give you quickly a run around on this model. For that, I hope I'm not too fast, and hopefully I'm not too slow, then not that you fall asleep. And so basically, also in this model, I have used the same technique using, for instance, a section box. Also here with the section box, I've given it a name. Hey mate, I want to use this actually for my analysis. And I can, for instance, figure out that also this view is somehow locked. So we have here on the bottom our view tools, where we can work with all kinds of detail levels, presentations, or also including some sun studies if you're after. And so I can, for instance, select here my crop box in my HVAC model, and also here quickly cut it off, and then actually focus here on the point of interest for that. Good. The thing is that when we have in our MEP model different versions, it's a little bit tricky to work here with systems and actually design options. So I have just taken and have made use of the existing system as it is, and I actually just put in the diffuser as they are out of the box, nothing special. I just actually put them and added them on, hence they come in actually into the other model. Because all what I'm actually after is the geometry of my room and actually my surfaces and actually the location to set up the boundary condition for my CFD model for that. Okay, so just somewhere for that. If you want to set up any systems, and you actually also work out maybe any required flows, for instance here in my example 235 liters per second, CFD and the boundary conditions do not understand this yet, though I have heard that CFD has an API somewhere. There might be maybe an option to bring this across, but on the other hand, you actually want to author this in your CFD environment anyway, so maybe something we can encourage maybe the development team to hook this up. But you know, software like this is not being developed just on a rainy Saturday afternoon. It always takes a little bit of a second for that. Good. What about these? Let's talk a little bit on how we get actually the model, what we have, into CFD. Let's pretend that we have modeled this, everybody is happy, and if you have any questions, we can talk about this afterwards. So I'm just here reloading actually my model here back in. When we install CFD on our on the workstation, we get actually a pretty cool plugin for that, which is actually pretty awesome. And somewhere, I think, not under my extensions, probably add-ins, we find here our active model assessment. So let's have a quick look what's waiting up here for us. So in case, if you have messed up your model, it doesn't matter, because here under the 20 folder, I have here the same model prepared already for the analysis. Okay? So let's check a little bit out what screenshots we have here available, and I might quickly explain what we want to do here in the next section. So we're seeing, good. So the challenge is now, when we actually model in Revit, that we find that Revit produces a lot of geometry. And always, it can also happen that we have maybe details like, for instance, windows available. We have maybe also some curtain walls available. We have maybe furniture available which are quite detailed. So this causes a bit of problem, because for my CFD analysis to work, I actually would need to mesh this whole thing. So, and as more refined my details are, as more refined the mesh actually needs to be. If I have a whole building and assume, for instance, you probably know that the smallest what you can model in Revit is 1/32 inch, smaller Revit, smaller project base point with a radius of 10 miles, that you don't get a problem. Doesn't matter if you have the survey point a little bit further out there, doesn't matter. So with my geometry, and I would produce theoretically a mesh, theoretically with 1 or 2 millimeters, because this is, I could go down to my detail. It takes an awful long time actually to calculate. So it's really painful to work for this, especially when we have a large building. Our building here, to give you some numbers, what we have, for example, that's about 20 meters. Sorry, in New Zealand we are metric. You can work it out yourself, what you would have in the US. And so we have found this here with about 20 meters. So if you divide this now up by 2 millimeters, it would be pretty painful. So the goal is now actually to have some simple surfaces you can actually load up with some boundary conditions. To achieve this, I wouldn't touch up every surface. I actually would start first to set up actually my view, for instance. So basically prepare the view, and then you actually make use in your instance parameters. You just turn on, turn off the categories you actually don't like, you actually don't need. And then we can actually focus just on the geometry we actually really need. So for that, good. So I will do now and demonstrate this now here, and just grab here the model what I have in the 20 folder. So open up this whole thing, going up here to 20, export here my CFD. I find here an Autodesk hospital prepared for my analysis, and I will quickly open this thingy up, and then we see what it shows us for that. Good. Because we work actually with categories, we turn on, turn off actually categories to master actually here our geometry. We can actually also work with view templates. So if you want to include this in your view templates already, to turn off categories like furniture or others, we actually don't require. This might be maybe a good hint to set this up. So I have called this view export me here as an example because I want to lead you quickly through a process on how we can actually simplify these windows here. What about this? Let's explore a little bit the family. It might be not that everybody is familiar with family modeling in Revit. If not, and you need content, just visit our booth down there. Otherwise, yeah, just select it. Select, inspect, and act is the idea how Revit actually works. And so basically, if I want to perform something, I actually select my object. If I want to model something, I select one of my tools for that. Good. And then I have my instance parameter as well as my type parameter, and I inspect these. I have 5 areas to inspect in Revit. This is my contextual tab I'm pointing at right now, my options bar, my properties, my type properties, and my symbols. So these are the 5 areas we have to inspect. There's nothing more out in Revit. Revit has a contextual user interface. So when I want to now double check how we want to work here or how I can set up my window is, you see that my window has an instance parameter here, Cfd simplified, geometry on or off. And as soon as, for instance, I turn it off, that the whole face becomes yeah, a little bit more cluttered, basically. So I can actually also here turn it on again, and I see my model, hopefully, if it's nice to me, more simplified or not. So come on, select it, and then be nice to me. Good. Let's take the next model. So that's why we have a couple of backups. So I select it and bring here and edit my family. For that simple family, as it is, for instance, here in my model. And what I did actually, I just have added on an extrusion, a simple extrusion on top of the whole window, so that I don't actually have to work with whole frames, because the whole frames would make it a little bit tricky actually to mesh my whole model. So with every geometry I model, I can actually make use of the instance parameter I have within my family. Same game, contextual tab, option types, properties, type properties, symbols, and one of the instance parameter is my visibility. And the visibility parameter I can actually connect and hook it up with a family parameter that I actually can turn it on, turn it off. So with this, I don't have to exchange in no way. I don't have to exchange the geometry. But what I can actually do is, if I have any model from any architect, it doesn't matter, I quickly sketch on top of it my simple geometry to suit me. So it doesn't need to be fancy, it just needs to be informative for my analysis. So when we model something, we also want to constrain it following ANZRS. Anybody did hear about ANZRS yet? Australia, New Zealand Revit standards. If you don't have them, just copy them. You can just go to www.anzrs.org. So we have there a bit of a pattern on how we actually constrain families, first from the plan view, then from the front, and then from the left. So hence, when we go then here, for instance, to our interior side from the front, we would actually also see here my extrusion I actually did. So we see that, for instance, even if something will change, I have just clipped the extrusion actually to the reference line on the outside. So in case when I want to move something, basically constraints not satisfied yet. And so when somebody still changes in my design phase, my window, and it updates, then I can actually, the simple phase still actually works with me. I can set up a project parameter. The project parameter we find is just here, for instance, under my analytical model for that. And when we added, for instance, this parameter, I have just used here simple family parameter, but in case somebody wants to export it, use, for instance, a share parameter. It's family parameter or project parameter, I'm sorry. So we have here, for instance, just a family parameter, and it's just a simple yes and no parameter. And with this yes and no parameter, I actually just drive the visualization of the family, of the geometry, actually, within my model. If somebody, of course, now asks, don't we actually have some other geometry? Or why don't we work when we have the geometry, for instance, with my visibility settings, with my detail levels? It's very often that window manufacturer actually make use of the detail levels for themselves, so that coarse, medium, and fine is actually blocked and locked up. So I can actually do my own thing here, and I actually don't need to rely on any existing families, because if somebody has modeled a coarse environment, it might not necessarily suit me, because they still have maybe some borders or some frames or anything else, for instance, here part of. So if you want to set this up, basically select here the geometry, and then the parameter we just set up before should appear, because it should automatically recognize that we have here a yes-no parameter, and with this yes-no parameter we can just, for instance, select it. So the other geometry, and I quickly may select it and delete this here quickly, the other geometry I can actually also hook up with my other parameter here with my visibility, and for instance, I would just, for instance, connect this now with CFD simplified geometry turned off. So when I would select this now, we see here there's equal signs on the side, and then basically when I go back into my family and go to switch off, then this geometry is then actually not shown, if you want to go there for that. Good. But it's not a Revit family training course, so hence I would just suggest that load into the family, no, forget about it. We just stay as we are. Just want to close this thing here, and we want to actually looking forward a little bit to our export, because this is actually what's here all about. So in case if something was a little bit messed up or didn't work the way, I would just quickly open this up again and to show you and run you quickly through the export for that. So with the export option, what we have available, come on, let's scroll a little bit further down. So we see, for instance, here as an example how I did it. So if you get the documents, you actually see that. So it also describes you how we can set up the project parameter and something similar that I've just shown you. Good. So it gives you a bit of an idea about the visibility. And so when we now export this, we actually have a model assessment available, and we would find the model assessment in the add-ins panel for that. So the question is now, what's the purpose of the whole model assessment? It gives me actually here some ideas about the how refined actually my model is in terms of some tween spaces, sliver spaces, small gaps, and others, which actually can influence actually my results that the CFD solver actually might not be able actually to solve it. So with this I can actually check and double check the integrity actually of my model. So let's see if this model actually just came up again. I will, for instance, here go here to my export me session, and here under the add-ins we find here our active model assessment. I would suggest we just quickly need to check this out a little bit, that we see a little bit what's involved in this whole workflow for that. If there's an error message, who cares? We have everything saved, because you can never know in a presentation if something goes wrong or not. So that's why I've prepared everything. And so brilliant. So we see here, for instance, in our CFD model assessment, our values we can actually work and play with and investigate this a little bit. Does this work on your side with the cloud if somebody wants to follow, or does the cloud lag actually on your side? Kind of all right? A little bit wobbly? Good. Then I try to slow down or just try to give a couple of hints earlier. So what I want to do now is here, I can now run through my potential model issues basically here. In terms, for instance, of any sliver spices. We see, for instance, from the model that we don't have any big issues, for instance, now with the windows, but here on the bottom, there's probably some structural stuff which might actually somehow pop through. When it comes to any parts or any gaps, for instance, here, we see that we actually kind of, all right, somebody was cleaning up the model already, that we actually can focus on the workflow rather than on CFD training. There are actually some cool other classes around. For instance, we have also here some sliver spices, and we see, for instance, here, when it hasn't been modeled that accurate, so that we get actually here some small sliver spaces. And this, of course, a little bit annoying when we try to measure, when we try to get some good results, actually. And this is actually what we do with our model assessment and see how does actually this model come in. In case if so, I can, of course, chase up the problems, and I actually can try to rectify the models in my design software so that I actually don't have the issue for that. Good. So, bring this up. Another solution is when we have all geometry available here, and I want to point out a little bit now towards and want to work quickly with the surface wrap here. I will not demonstrate how the surface wrap looks like because it might take about 20 minutes quickly to run through this, and I actually also want to show you another workflow on how to get actually a good kind of alright data into CFD. However, I think that the model assessment is actually initially it's crucial because it actually gives me, as mentioned before, some issues where I find it. You see actually when I select it that where these issues are on the side, and it might be maybe that we just have some random rounding issues with Revit or somewhere else which are basically being caused for that. So good. So let's check a little bit how the surface wrap actually looks like. So, brilliant. Going down. So with the surface wrap, we actually need to have a resolution. The problem is when we have even though we have a very fine resolution, and it creates a wonderful, great wrap around, it actually just very often rounds some of the corners actually off. And sorry, I'm a little bit picky about this, might be just me, but I don't want to have my corners round. Okay, so this is a little bit nasty. And so for this, yeah, I wouldn't do it. If you have, for instance, a building in general, if you use CFD for any structural analysis and you have your flow from the outside, I would not have any issues with this because it's small enough, but not when I do some interior. I don't like this. So it might be also just me, basically, and I don't want to keep them and make them actually around here. So you see then after a while that it would generate a wrap for me, and this wrap I can actually then transfer to the analysis afterwards. And I wouldn't have any small issues or any sliver spaces anymore because it would basically create one complete model, and it would basically literally wraps it, including some external volume, for instance, like what we see here. You see that the external volume is quite coarse in my case here, and we see, for instance, in the next screenshot here that just on the shading here, oh, but that's a funny color. Let's try, maybe if you want to use yellow here, that it actually just rounded everything off, which I actually don't want for that, because it's probably not something everybody might want to basically use. So I can make use here of my model assessment actually to run through. Also, if you want to, for instance, under the View tab, I have commonly my styles here. If you want to work, for instance, here, if you want to, I think I also want to have it maybe a little bit shaded, or actually want to work here also with a wireframe. So commonly, like you would have it in Inventor, or also what we find in the CFD tab, that we can do so. We can touch up a little bit our user interface about the model assessment and have our common navigation tools here on the top, for instance, on the side. Good. In terms of my model assessments, we for instance we have also here some other interferences we can actually check. And you see, for instance, here the geometry I have modeled, but I didn't turn off because I haven't connected it with the other parameter. If you are following, obviously it highlights basically that here are some interferences, for instance, for that. Good. For that, good. So, do we have anything else? No, okay, we can connect it with Vault if somebody's interested. And then, but I think we should leave this because, do you want to close this model assessment? Yes, why not? We want to quickly go back. If you want to export it, I found it pretty cool actually to work with Z files. So I'm a pretty big fan of Z files. And when I want to now export this file, just Z file, we can just go basically to the export button and go to the CAD files and just basically go to the Z export. What we have in Revit here available is basically what you see is what you get. And I think hopefully going further down, we have here our Z export now, because Revit actually has here 3 different layers how it works. We have our relational database on the bottom, which is basically a lot of tables. And all these tables, they're actually connected and wire up. So this is where all my changes and all my updates are actually happening. This means that the view has been generated, and later on, this is kind of an AutoCAD's language, it would be kind of a model spice, followed by a Piper spice in good old AutoCAD language, or in Revit we would say basically these are my sheets. And when I want to have my view, which has been generated, I actually just need to drag and drop this on my sheets. So with my model spice, what I prepare here is simply what I actually get. So hence I can work here with my visibility and graphic. I can work with my view templates, and I can work here also with any instance parameter of my family to turn on, turn off something. And we see this here, for instance, as an example, how this generated model spice in AutoCAD terms has been, or will be, for instance, exported. So let's try it, and then we see how we can actually bring it in. So we find this, for instance, here under the export. We find this here at the bottom on the top. We can go to our CAD exports here. We find actually also some other exports like DWG export, for instance. We find also here some other FBX exports. CFD offers me to import Z files and FBX files. Z files are pretty much good solid files. Revit works on a Z kernel, so and that's actually pretty cool. So I have my view as prepared. I can just quickly go here to my next, and we see, for instance, here already the file I actually have already prepared in case something would have crashed. But I just, for instance, just dump it, for instance, here on my desktop, that we at least do something. Just takes a second. So I actually don't need to work for a big wrap or anything. Also with the wrap, it's sometimes tricky to actually to assign some other boundary conditions, and here's some surfaces, which actually works a little bit better here. If you want to export this as a CFD as well, we can do this here as a CFD the same way, the same manner. The only thing is, don't work with the level of detail here, just keep all the amount of details we actually have, and then should be good. But preferred shall be, for instance, to use the Z file for that. Good. So we have this exported now. I think we need to run a little bit through any type of analysis. So I'm just closing this model, just not to stress my computer too much at this point. And somewhere you should find under your start button that we have here a CFD 2018 tool, a 2018 application. It might take a minute actually to fire up because it's a little bit of a bigger application, but it makes a lot of fun. So if somebody asks, my laptop here is running on a 32 gigabyte RAM, so works actually pretty cool for that. Good. Great. So when we are now here, before I give you a little bit of a time till CFD fires up, and then we can explore also a couple of results. As mentioned, we don't need to calculate this whole thing. So under 30, we would have here some CFD projects if somebody wants to open this up, and the project of interest would be here, for instance, under the analysis, set 18, and there we have a CFD study environment. This will be the file we want to open up in a second. So what's coming up? Here under the 35, again, the screenshots, as I mentioned before, and I quickly want to run through what we want to do and what we want to actually explore for that. Good, so our CFD projects is what we have available. Good, so when we import my set file, again, I actually have the option to clean up my geometry. Working here, for instance, that I want to merge any edges, I can clean up any small objects, I can fill any voids, or I can also work with any external volume. Similar, what I would have, for instance, in my what you just saw in the wrap before, in the screenshot. But again, not mainstream. Mainstream would be, for instance, using our set file here. Good. So I want to bring this set file basically in. I want to set up a tiny analysis with you that you get a bit of a feeling what's actually involved. It's actually not rocket science and not too complicated for that. Good. So, for instance, running through on how we can merge, for instance, some complex edges, for instance, removing some small objects, and CFD does this actually pretty awesome and pretty cool for us. And because it's not a CFD training, I just have created an external volume. We can also adjust with our arrows here. Works actually pretty cool, pretty nice. And then I just create here a little bit of a pressure coming from a bit of a flow coming from my diffusers actually for that. Good. So external volume. It will then you have, of course, we have a lot of geometry here on the side. So we will see, and these, of course, need to be assigned with a lot of materials. We will see how the material browser would actually work here in CFD. So you get a bit of a tiny demo. And we also need to apply some others. While we can actually also apply here maybe sun radiation or others with the surfaces. So it's pretty cool what actually CFD does. So I really love it. So so after we have turned all the unassigned stuff into some assigned materials, and because we're actually not doing any thermal analysis, we just do a simple flow analysis for the point. We can just use any kind of material, basically, anything which is basically solid. We can assign here. And then while we just want to here maybe turn on, turn off a couple of, or hide a couple of objects, then we want to make use here of some boundary conditions. For instance, here I did set up with my first port of call just for diffuser here at this point. What we actually also can do is that we can actually also clone the case, and when we clone the case, the same material what we have has been actually reused, and I can, for instance, also update here my diffuser with different boundary conditions for that. Good. Then, of course, we need to mesh this whole thing because it's the whole key why we try to simplify actually the geometry here. So that's the key for that. If you can't mesh it, you can't calculate it, you can't do the number crunching. So that needs to be a bit of experience. Then we set up basically our results and our quantities, and then we basically can inspect our results. So we don't run it because otherwise the computer might be a little bit busy. And but we want to experience a little bit how this works, and then we can, for instance, set up the CFD design study file what I have actually prepared. I think it's for the 7 diffusers what I have uploaded for that, so it doesn't matter. It's just that we get a little bit of a feeling for that. Good. So our CFD. If you want to create something new, we find here new on the left top. We want to create a new design study. And so we have now the option to browse for the model. Yep, model we have it. We can also give the design study a little bit of a name. When we browse the model, we probably find here under our 30, hopefully, the set file, which is the set file I've prepared. It's actually the same set file I've just exported on the desktop. 101 is actually the same for that. Good. So, by the way, if somebody wonders what kind of geometry you can actually bring in, because you might use some other design software, be it, for instance, using some Fusion set files, Inventor files, some step files, Pro Engineer if somebody works with them, or Alias, which are also cool software. Somebody is still working maybe with SketchUp. Better you work maybe with Format. Anybody knows Format? Format 360? Yeah, very good. So, bring it in, and also good old alias wavefront files, OBG files we can bring in as well. STL files we can bring as well, so if anybody wants to CFD his files, he commonly 3D print, because it works with a mesh, we can bring this in as well. So we have here our set file, we can just open this up, then we need to just give our study a little bit of a name. We could call it, for instance, here AU 2017 or something like this for that. Good. So if somebody wants to now jump back because you got the set file from somebody else, we can again create here model diagnostic or surface wrap, the same stuff what you have just seen before. We don't want to do this, we actually want to create here something. So after I have my file, design study, we actually want to here create something. The computer rattles for a second, it's reading the file, and it's creating and building actually the model for me. This is a typical picture from CFD not responding. Good. Brilliant. And then my geometry tools become hopefully available. They become available. Brilliant. You would work yourself through this whole user interface from the left to the right. First my setup, then my results, and then my decision center. View, some auxiliary tabs where we can actually look and work with our views we actually have available. We see here on the left hand side that any kind of sliver space actually became a tiny part on the left hand side here. Can happen, can't change it. So we have here our edge merge, our geometry tool available. So we can go here up to 15 degrees. It would merges, and now we see, for instance, here also that it highlights actually the edges here basically of interest. If somebody wants to navigate with this, you can use your middle mouse button to pan it, use your shift to orbit it like it would be in Revit as well, and then you can actually use also your wheel, for instance, to zoom in and zoom out, and then you see this. So we see actually also the arrows pointing out here the points of interest, the edges it actually doesn't like. And so it offers me to simplify it a little bit. And what I can do is just click, for instance, here on merge. We see here how CFD actually talks back, and then we actually shouldn't have any issues anymore. Same thing is that next we actually can go to small objects. With the small objects, I can have here a bit of a play with my slider, and then of course I should see some or no objects here, more or less. In our case, we don't see it. Well, good. Secret is I've prepared this model for us so that we shouldn't have any issues with this. Good. So void fill. We have the option to fill any voids or so. This is especially very interesting when we, for instance, let's say, for instance, have a pump and bring this pump, for instance, here in. Or I have a valve or anything else similar with that, which we open up. And it comes, for instance, here with the hole. So basically what I can do is I can select actually here my border and actually can close it up. Because what CFD requires is actually a volume, because on a volume I can assign actually my boundary conditions, be it, for instance, a volume flow, be it a pressure, be it some temperature. So where nothing is, nothing can be calculated. In our case, we have bypassed this with an external volume. So when I click here my external volume, you see a little bit the extent of my volume. I can actually also, when I hover with my mouse over it, I can actually also adjust it. However, when I go a little bit in, it jumps back because the external volume is pretty clever and figures out, hey, I'm actually not enclosing this model completely. So that's why I'm actually going back to my minimum extent. for that. So if anybody wants to have a bit more, if somebody wants to do some wind tunnel analysis, so this would be then your game, this would be then your toy you want to play with, when you want to bring maybe your car, for instance, in, or something else, and then we can, for instance, here then create actually the external volume. We see now the external volume as I did create it now, and we should also hopefully see now under my assigned an additional material. So sorry, an additional piece of geometry. We see a lot of geometry here, pretty typical for all the AEC models. And here we have here Cfd Created Volume. This is just the piece of air we actually have created. So when it comes now to the materials, to set this up, we have a couple of options. Either we click here, because you see that we actually jumped further, we jumped to the materials. We can go here using the right mouse click. And under the right mouse click, we have our common menus, like we can use it shaded, outline, or transparent. And then we go, for instance, here and click maybe here on edit and set up, for instance, here my material. Okay, it's not diesel fuel, obviously. Can happen to everybody. So we have all kinds of available, be it solid, be it fluid, and somewhere we should actually also find here some air, for instance. If somebody wants to do some other stuff, some electronic stuff, we find this here as well, so heat exchanger, heat sink, or circuit boards, or just some pump or blower, or maybe some fan or pumps for any cooling as well. So in our case, we're using the fluid analysis, so it would be basically air. And so when I would apply this now here to my to my environment, apply it, you see that here the volume actually jumps into a straight nice material. Because the other one it's actually not that important, because we just do a flow analysis. They could be basically any kind of material. We can actually do a complete selection here and use a right mouse click. If you want to select this individually, you can do this as well. And for instance, when you select, for instance, this, I quickly go to the outline, for instance. And then, for instance, you can actually also here select your model, for instance, here inside. If you don't like this, we can actually have also here the option to temporarily hide it. Quickly bang and hide this whole material. Right mouse click, then we can show it again, and then we can actually here touch up, for instance, also our material. So, for instance, here I can go to my floor. You see the floor highlights, and go, for instance, to my floor, and go, for instance, here hide, and then I can actually see this from the bottom, orbit this quickly, and then set up my boundary conditions. Before I finish, go to my boundary conditions. Obviously, I want to set up the materials. We can actually also go here, should finish the materials. We can select it, edit this here, and say, for instance, I would like to have maybe something solid and just make something up, steel, iron, whatever you're maybe after. Maybe we have some glass, brick, maybe some concrete, I think I have chosen. And then, for instance, apply it, and you see how it then actually fills up for all what I actually have selected here, including also currently the unassigned ones for that. Good. So, which would mean, for instance, I need to quickly change this around because my air is not, it's not a solid actually, it's actually a fluid. Quickly apply this, and then the other ones, they are concrete, and if the other ones here, I can do a multi-selection, right mouse click, edit it, and then I can also say, so it should be a solid. Concrete comes up because it was my pre-selected one, and then we can quickly apply it, and then everyone should be actually happy here for that. Good. So when it now comes then to the boundary conditions, I quickly tilt my model, and we find boundary conditions up here. Boundary conditions help me that I can actually here select what I want to select. I can select a volume, I can select basically a surface. When you select a volume, you mostly find, when it comes to the boundary condition, that's, and I want to talk about boundary conditions, please, that we most likely have here now our surface. Actually, I want to demonstrate first what's happened is when we have a volume. So when we have a volume, edited, then we actually can only work here with our heat generation or total heat generation. When it comes to any flow from our diffuser, I actually would need to select here my surface, and then I can actually here selected, or when I just tap on it, also go here, like in Inventor, for instance, my submenu, and it would be, for instance, that I have a velocity, or I have maybe a volume flow rate, which would be maybe a certain amount of liters. We could set up, for instance, let's say 200 whatever liters, and then let's see if it actually accepts it. And when it accepts the boundary conditions, we actually see here the volume flow rate actually going down here, highlighted with our marker, and then you just need to work yourself through the other ones as well. For instance, through the other surfaces. For instance, I started here with the 4 ones selected, for instance, and I go, for instance, also I want to have maybe a volume flow rate. I want to have maybe here my liter per minute, 235. Maybe let's do a different one. Maybe we don't want to blow so hot, and apply it. And you see, for instance, that here these are being then added on here to our boundary conditions on the left hand side. So, for instance, here the next one, and so on. Good. So once we did run through the boundary conditions and have, for instance, all 4 set up, we can actually also work with our initial conditions. Initial conditions means everything which is not relative to 0 degree. Celsius in my point, so if something is maybe 20 degree, or if maybe in temperature, if I have some initial temperature, if I want to check how to cool down the whole room, I would set up my initial conditions, not important for us. And on my mesh sizing, I have here I can set up if I want to have a manual size or an automatic size in my mesh, and then I can go here maybe quickly to say, okay, auto size this whole thing, and then we see here a little bit our bulbs actually around. So, sweet. To move on, you want to theoretically maybe solve this here, but don't press it, because otherwise you won't have access to the machine unless you need to go here to a job monitor then and actually stop it. And so we want to, for instance, theoretically would save all my intervals, and then I want to, for instance, look into what I actually want to calculate. Smoke visibility is actually pretty cool in case, or for instance turbulences. It would be in our case just basic our flow values, what we would be after for that. So if somebody wants to open up one of the rendered models already, calculated models, we can go quickly to the open. So I want to open up now the other models and show you how the results look like, because there's a bit of a key buried we need to understand when we want to export this. Do you want to save the design study? Nope, not at this point. And somewhere under the CFD projects, we should find our analysis from set file. This is the 18, and somewhere you should find here under analysis from set file. Just open this up and see what we actually get. Our lovely picture again. I'm not responding, but hopefully it should come back and should come up in a second for that. Now, come on, be nice to us. Good. So when it comes to the presentation, it's actually pretty straightforward, because I can quickly show you what's coming up here. And so we find here some of our markups. That's also wonderful, great, easy, cruisy, and cool. For instance, here some of our planes where we can actually visualize our results. For instance, here. But the key is, even though we have here all kinds of traces, for instance, then showing, for instance, here the flow of anything of our what we have in this room. The key is actually that we can actually export our analysis with the help here of the nodal results. And it doesn't matter which software you use, if you use Max or if you use Dynamo later, they actually can visualize this. And so this is actually pretty easy, pretty cool, straightforward for that. So we have this just to show you here how one of these planes, for instance, work. So these are basically my results. I can actually visualize here through my CFD, blah, 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 and so on. And I can browse through, have some editing and so others. If you're interested to learn more, do a CFD training, and then we find out. Good. Under my export, these are here the nodal results where we can export it. So all the mesh nodes are being exported here. And so I just click here on exporting nodal results, and they're actually being written back into our solver file. So where's this being stored here? When we would go, for instance, here into the 30 CFD analysis from set, we find here our AU with our 4 configurations. We find here under the solver, somewhere when we scroll down, there are some heavy databases running in the back end. So if you wonder why this is 60 gigabyte, now you know it. We find here our CSV file. And the CSV file is actually pretty cool. I'll just quickly open this up here. No. And quickly loads it in because comma delimited file, it gives me all my nodes with all my velocity, literally everything. And so this can be brought in, for instance, to 3ds Max. Let's check out 3ds Max. Please open up 3ds Max. The computer might take a bit of a second. So from now on it gets a bit more interesting. I want to show you some examples. So I don't want to do this now with Max with all 820 because this might take a bit, about 15-20 minutes. What I've prepared is a small file which 3ds Max comes out of the box, but nevertheless I want to show you that it's actually possible with the large ones as well. So first we always double check the system Unix and double check actually the project folder in 3ds Max. Then of course we can here start a new project and save actually our scene. Then I'm looking after my grid file, after my grid actually in 3ds Max. And you see actually there's just a couple of minutes to bring this actually in. So when you have the analysis anyway already, the most of the time is actually being spent to touch up and to work with the model itself. You can bring in, for instance, now the geometry. And then we can actually bring in also the CSV file. Here on the side we see this here that we have a CSV object. We do this with a small file as I've just shown before because I want to show also the simplicity for that. And then for instance we can here see our CFD. We see here all the nodes and the results then in 3ds Max, and we can apply any kind of concrete material, for instance, to our geometry. We can render it and visualize it in 3ds Max. And then we need to have maybe a vertex color map, for instance, with it. But the problem is that the vertex color map is not being transferred to Stingray and basically render this. So rendering takes also a couple of minutes, so that's why we skip these. But take the file if you're interested, and you can actually also set up a camera within. And so, good. The key is then that this geometry, that these arrows, they can be turned into polygons. And that's the key if you want to export it to any, if you want to go from 3ds Max actually to Stingray, for instance. For instance here. Good. So, let's go, for instance here. I might close my CFD because we don't need it. We have everything exported. We're actually all happy. And let's go, for instance, here to 3ds Max 2018. Just quickly open this up. And the next 10 minutes, maybe let's dwell on it and how we can bring it in. And then let's move on to Dynamo, because I believe that many of you will probably use the Dynamo way for that. Good. So we don't want to work with the big model because with the small model, I actually have here a couple of other examples. So for this is round 2, is here, for instance, our practice round. So we have here our 3ds Max obviously up and running. With 3ds Max, obviously we first check actually our units, because this is relative to the geometry, how we actually exported it from CFD. So when you go to customize, we find here our unit setup, and when we bring up the unit setup, we find here actually also then my units and our system units. So again, that was here under the customize. I can go to my unit setups and I bring also my system units. The system units in my case, for the next one, they need to be in inch, unfortunately, because the example model comes with 3ds Max out of the box, which is here in inch for that. Good. These are my display units. If you are happy to work with US standard, go US, sorry, in New Zealand we're metric, so I might leave this here in millimeters, please don't hold it against me. Good, so next one is that we have actually also a project folder, where we actually want to go there, here set the project folder, and when we set, for instance, the project folder, we have here, for instance, on the desktop, or commonly under downloads, we have my 3ds Max project folder. If you want to set up a project folder, you can make use, for instance, here under the AU, and under just under 40, just select, for instance, here 40, 3ds Max, and then you're actually fine. And then hit, for instance, the OK. Good. Some of the other paths are not valid. Commit to this anyway. Doesn't matter, for instance. Good. So next one is when you want to touch up a little bit our grid to get a bit of an idea. We have here our snap, our 3D snap. We just would need to go to a right mouse click on the 3D snap here, do a tiny right mouse click. Then we can snap to a vertex, to a grid point. Please select both. So we have a vertex and we have a grid point, because we want to later on here snap to our center. And then, for instance, on the home grid, we see, for instance, we have 250 millimeters of that, which gives me about 4 meters, something about this. I could place, for instance, in this area here, it's all right. And then if you want to have something straight here, do something straight, and you see actually how this actually updates. So now, super easy task, super easy task, long story. I know a long talking it was. We find here under the create our CFD stuff. So please just go here to your control panel on the right hand side. We find the control panel. We have different tabs here on the top, but we stay just with the first one. And we have here where we create some solids. Here under the standard primitives, I just need to get my pull-down menu, I find my CFD, and I get here my CFD object type I actually want to bring in. Okay, sweet. So I can now go, for instance, here, import my data. When I click on import data, it opens up that we want to have here CFD data and parameters. The CFD file here is actually the CSV file I was just pointing out before. And here I would just need to go to my CFD file, and there's something coming up out of the box. Remember this path, C, Program Files Autodesk, 3ds Max, Scene Assets, CFD. So if anybody wants to practice this and want to have a bit of a play with this, you can actually here have your tiny office, actually, if you want to bring this in. Later on, we will also import, for instance, here our IAC set file. For instance, we can do this actually as well. So open this. When I click on open, I would need to have my snap activated, and I just quickly go to my sender. I quickly bang, press the left mouse button. Then there's something happening that I don't see anything what happened. And this is probably a bit irritating now, but it's just the nature of the beast, I can't change it. So what we find is here on the left hand side, it is actually here part of my Scene Explorer, and I can actually select it. Well, I can also, when I select it here, I can go here to my right mouse click and go here to the properties. Okay, so again, what did we do? I went here to the CFD input data, CSV, I just redo it if somebody got stuck. Office, open it up, and just with the left mouse button, bang, to the center, to the origin, and we see how this has been added up. Go to your properties, and what you will find with the object properties, if you're not familiar with 3ds Max, just trust me what we do now. With the object properties, I just turn off this here by layer, and everything becomes available. So I want to, for instance, turn off my vertex channel display, turn on my vertex channel display. I want to maybe also have some vertex ticks and so on, and I want to actually also display this as a box. Right? Good. So even that doesn't do much at this point, but display as a box is actually important so that we actually see what we actually do here. Okay? Good. Hit the OK. So here is actually our wonderful, great box. And we can use our wheel to zoom in, zoom out. If you want to orbit, use your Alt key, not the Shift key with the middle mouse button. Then we can see actually in orbit actually our box. Good. So what next? So we want to have here, I think, a velocity. So when we go here into the velocity, it asks me now here to select my CFD input object. This is my CSV file. I actually here want to select here CFD input object, and you can actually select this here. For instance, also here in the Scene Explorer, and all what we need to do is now here from this, in my origin again, press the left mouse button. You see the computer rattles for a second, and then we actually see here our arrows coming up for that. Absolutely awesome, absolutely cool and brilliant, and so super simple and easy. I just turn off my 3D snap again and just wander here a little bit around. Okay, if somebody wants to bring in the other geometry because you want to render it, you could do it. Just go under File, go to Import, and just import basically the other set file we actually have here somewhere. You could basically bring it in. In our case, I just leave it because we are focusing on the CFD data. We don't do a 3ds Max training course. So when we now have this here, also we do the same game now with my velocity field here. Right mouse click, Properties, and also we want to here override this thing here by layer. I actually also want to here my vertex channel display. Then maybe also in case you can do it as a box or something like this, or you can also work here with the vertex text, for instance. Good. So now we see that this is looks a little bit funny because it's basically blue. These are our vertex ticks we actually have. But when you zoom a little bit in, we see here actually the nodes and actually here the arrows. So if this blue annoys you, field here, I go just back into my properties. I can just turn off here my vertex ticks. If you just want to display it as a box, similar like the other one before, this is also what we can do is here. Brilliant, fantastic. And then we actually see here our basically our values. So the values are not in any way assigned at this point, so we don't have any color we actually render. We can just, because this just shades it in my viewport. If you want to add on the material in my 3ds Max, we go to rendering, and we need to go to my material editor. We find the material editor here, and we can go here to the slate material editor. So just go to rendering, material editor, slate material editor, if you want to follow this, and then slate material editor actually comes up. We can make use of all kinds of different materials here. So what we actually need to do is we need to quickly compose our own materials. This would be now that we go here to our general and bring in here our scan line, bring here our standard, and after the standard we have also here some maps where we find here, for instance, some vertex colors. We can maybe turn this up with the diffuse, so maybe our self-illumination, and then we can just assign this here, drag and drop this here in our vertex field. So if I would render this now, then I actually would see the nice color. If I want to now present this in Stingray, and we have, for instance, Stingray up here, we can actually just open up a Stingray, any Stingray you have available. I think they have put 1.9 on, and so bring this basically up here and see this and have a time perform license authorization and so on. And when we start, for instance, a Stingray project, we need to actually grab a template and actually export my model to Stingray. So for instance here, we can just make use of any type of template, be it you work with an Oculus, you work with an HTC Vive, or with a Google Cardboard box, whatever you basically like. And then you can just, for instance, create this here, and then create this wherever you want to be, just to show you how easily you can actually export this. So this, for instance, also then presented a little bit further down the track. So the same model what we actually have here, I have this here in my documents as well, highlighted. If somebody looks into this, I actually also bring here the file, just the same picture, what we have just seen here, for example, and then visualize it and shade it, for instance, here. Good. So if you want to shade it here, you can go, for instance, here, just go to Materials, shade it with Maps, and then you see actually here that it actually uses the color from our vertex map we have just actually assigned So that was here under standard materials, shade with maps. Shade materials with maps. That's what we have available. Good. So, sweet. We can connect it here. So we can here connect actually here with my Stingray project. We can actually also create, for instance, here create a new level and actually transfer the data. And then all what we actually would need to do is, for instance, create a new level, for instance. And for instance, in this existing level, we can just here in the Stingray actually, when I find it, connect it. And then immediately I can, everything I have, I can actually export it to Stingray. The only thing is, I can only export polygons. So what I actually would need to do now is, in 3ds Max, I need to select actually my vector field. You see my Explorer here, I've just turned it off, like it would be an AutoCAD layer. Explorer here, turn it off, and have here just convert to polygon. This might take a couple of minutes, that's why we skip it. And we actually also skip this path because I want to show you a much more interesting way, also a very fast way, on how we can actually present this data. So the idea is that we make use of the nodal exports for Dynamo. And if you don't mind, go just flip back to Revit. Just forget about this 3ds Max. This is all kind of wonderful. Don't save it. You know that you can have a play with it. Nice Stingray, brilliant. Wonderful, great YouTube videos about Stingray. And when we, for instance, open this up, we find a folder in our class which is around the Revit Dynamo, which is the 61 here. And with this Revit Dynamo, we can actually here bring in the model. For instance, I have here the 4 diffuser model. And how this is actually working with Dynamo is, I want to quickly also show you the Dynamo script, because you will see that it's really, really simple. You can explain this to somebody really literally in 2 minutes. So that's why it took so long before. Quickly to demonstrate what's coming up. So we had just seen this, how we work with Stingray. But we see with Stingray, obviously, that unfortunately it's just black and white. So no materials we actually have, unfortunately. So Revit Dynamo here. The idea is here that I take actually my data and actually convert this data from my CSV actually to an Excel file. You can also use CSV file in Dynamo, but my standard language uses here using Excel sheet. And the Excel data can actually be read out, can actually create geometry. For this, I have already created some geometry for us. So I have basically an arrow, and this arrow is just an adaptive here family here, and based on my placement point here, and the size of my parameters actually size the arrow. Super simple. So basically, they size the arrow. And what I can do is that I can actually place this arrow about 820,000 times in my model by reading out actually my Excel sheet. So I have my Excel sheet running through and update this. So this is actually what the Dynamo script actually does here. So the question is now, how does this work with the color? Because of the values we actually have, maybe I should take another color. Because of the values we actually have, we can actually build up basically some text. And with this text, I can actually call upon a material. Only thing is that I need to have a good material library and have this already available. So, for instance here, the 4 diffuser model, for instance, if you want to let this run, there should be somewhere under the families, there should be somewhere under, hopefully in the generic models, somewhere a data CFD pointer. And here with this data CFD pointer, I quickly show you how this error is actually working here. So that's basically the error here with my parameter. And let's quickly flex it. So what did I do? Just to show this again, Just the model I just opened up under the 60 has here my families on the left-hand side, and under the families I have here a generic model. And under the generic model, I find here the data CFD pointer, and under the CFD pointer, I have a right mouse click, which is here just simple edit. If you let this run, it runs 10 hours for 820,000. However, the idea is, which is much smoother, is that throughout the whole day, I can actually prepare my CFD analysis. At 4:30, I just press on the Run button of my Dynamo script, and at 8:30 in the morning, I come back to work and actually everything in my model. Just need to keep the computer running and hope that we don't have any power shortage or something like this. So, good. So this arrow is a face-hosted family just here on my work plane, and the reference line can be actually flexed. So similar like what we just did before in the other family, we can go here and quickly flex it here. So when I work, for instance, here with my 200, quickly apply it, bang, we see that the arrow obviously goes up, because in my vector I have in my Z velocity is just 200 millimeters per or meter, liters per second, or whatever speed, or meters per second, whatever speed you actually have here. So goes a little bit negative. Why not? Bang. Okay, bang. Goes, for instance, negative.